Hello children. Today in this YouTube video we are going to study about few optical concepts related to haloalkanes and haloarenes. So in order to understand this concept, first of all you have to go through the video which explains nucleophilic substitution reaction. That is your SN1 and SN2 reaction. So there you have studied inversion, retention. So they all were the optical activities related to haloalkanes and haloarenes. So first of all, I would like to start with the very small and the basic concepts. That is, what is plane polarized light? That is your PPL. See, light is an electromagnetic wave. That is, it has an electric and magnetic characteristics both. So when light travels, see, this is the speed of light, 3 into 10 to the power 8 meter per second. When light travels, this is the wave of the light which has an electric as well as the magnetic waves, and this is the speed of light. So the electric, magnetic and the speed of light, they all are perpendicular to each other. The moment you supply this light through a nickel prism is a Polaroid. Polaroid means it will convert 3D light into 2D light. Now, the moment you you pass this 3D light, or you pass light from nickel prism, it will convert it into two-dimensional. That means the light, which was the vertical component, it becomes like this. Clear? Now it has only two axes. You can see here, not three axes. It has two axes. Okay? So, this Polaroid, you must have seen in the sunglasses. Why this Polaroid is used? Polaroid is used, or you can say plane polarized light is used to give a better vision, a clarity in the vision. So better vision, plane polarized light is used in LCD. That's why LCD pictures or LCD images are more clear, or you can say crystal clear. I hope you have understood this plane polarized light concept. Means passing the light from a polarimeter, or you can say nickel prism or a Polaroid, and giving it a two-dimension property. Now next is your chirality. Chirality. In order to understand chirality, you pause the video and look at your both the hands, both the palms. You will observe that you cannot impose your left palm on the right palm. Means they are non-superimposable. Now, chirality means hand-like, unsymmetrical. Now, when we study symmetry, we have to study few elements of symmetry. What are the few elements of symmetry? They are the plane of symmetry, axis of symmetry, center of symmetry, and alternate axis of symmetry. So, you need not to study this alternate axis of symmetry. You only need to understand PAC, that is plane of symmetry, axis of symmetry, and center of symmetry. So, as you can see in this bond line notation, this is the wedged chlorine. Okay, this, if we try to cut or try to separate this molecule into two half from the center, it is non-superimposable. ये एक दूसरे के ऊपर overlap या superimpose नहीं होगा. इनके mirror images पे भी they are non-superimposable. But if you separate, or if you try to separate this molecule, you will observe that they are in this plane of symmetry. You will observe they are superimposable on their mirror images. That means non-superimposable on their mirror images molecules are known as chiral molecules, while achiral molecules are those variety of molecules which are superimposable on mirror images. Clear? The symmetry, the mirror images, superimposable character. Okay, now moving ahead. Now we'll study enantiomers. Enantiomers are those types of molecules which are optically active. Now optically active means you can see, you cannot superimpose. Optically active means it can rotate the plane polarized light. Okay, so this is optically active, this is mirror. So this cannot be superimposed, means इसको as it is आप इसके ऊपर रखेंगे तो वो superimpose नहीं होगा. Means they are non-superimposable mirror images. Now if you see this example, just see, this is the dash notation, this is the wedge the wedged area where chlorine is attached, this molecule, if you try to superimpose on the other molecule, the first molecule on the second molecule, you will find it is not at all superimposable on its mirror image. Clear? Enantiomer clear? Non-superimposable mirror image. Remember the molecules, then only you will understand the concept in a better way. If you remember the concepts with example, you need not to mug up or learn up all the things, you will understand in a very easy manner. Now next, very small topic, diastereomers. They are not the mirror image of each other. So they are not mirror image. Whether you take whichever molecule, they are not the mirror image. Means if they are not the mirror image, then they are the diastereomers. Now the racemic mixture. Racemic mixture you will see in nucleophilic substitution reaction. If you have studied, you will understand this better. Racemic mixture. If I take these two compounds, okay, now here you must be confused with D and L. So in order to understand D and L concept, let us go through the DLN RS concept. Now see, first of all, we'll understand the DLN concept. DNL concept is used for optically active compounds. First of all. Second thing, we'll understand this with the help of glyceraldehyde molecule. This is a glyceraldehyde molecule. D and L molecule are such type of molecule. Suppose this is a plane polarized light. If any substance or if any substance in a solution rotates plane polarized light towards right, like this, right, then it is a D form. And if the plane polarized light rotates it towards left, this is left, then it is L form. Also one more trick, in case if the OH is on the right, then it is D form. If the OH or you can say HO is on the left, is the L form. So I hope D and L concept you must have understood. Now let us come to the racemic mixture. So racemic mixture, DLN is there. Now one more concept, R and S. R and S. R is rectus, S is sinister. Rectus means something which is moving towards right or towards the clockwise direction. Sinister means anti-clockwise direction. Now you understand this with the help of this molecule. See the wedge notation. See the wedge notation. See this dash notation. Now you can see there are 4 different atoms attached to the carbon. Now let me make things clear. You just imagine this in the form of a swing. This is a swing, carbon center is a swing, and there are 4 children sitting here. If the swing moves this side, that means it is moving towards clockwise, then it is rectus. And if the swing moves towards the left side, it is known as sinister. Now how this left and right side is understood with the help of molecules is based on the priority. So hydrogen is having least priority. Okay, so priority means this will move this side. Hydrogen having least priority, this will go this side. That's why it is R. And in case if in any molecule, if it is moving towards the anti-clockwise direction or towards the left side, then it is understood that it is moving towards sinister or S molecule. Okay, now coming back to the racemic mixture, it is very interesting. Listen to the story. You will understand the concept in a nice and easy manner. These are the D and L forms. Okay, if I mix them in equal quantity, means they are the enantiomers. Clear? They are the enantiomers. What are enantiomers? Non-superimposable mirror images are enantiomers. Clear? If we take equimolar mixture or you can say equal mixture means 5 gram of D, 5 gram of L. If we take them, we mix them and make a solution. Then we pass this solution from plane polarized light. So plane polarized light, you think what happens? If there is no rotation, if rotation is cancelled, that means mixture is optically inactive. Optically inactive means it cannot rotate plane polarized light. Now if you are thinking it is not rotating plane polarized light, then how it is DNL form? My dear, if it is DLN form, that means equimolar mixture, they are equal in quantity. One is moving towards right, one is moving towards left. They will cancel the rotation. If they cancel the rotation, it will neutralize the rotation. There will be no rotation. Hence, we will observe that this racemic mixture is optically inactive. I hope you must have understood the concept, and then you will understand the nucleophilic substitution reaction and the difference between them, that is racemization, inversion, retention, in a better way if you have understood and watched this video. I hope you have liked the video and understood the concept in a better manner. Thank you and have a nice day.